Hello and welcome to our presentation on logarithms. Today hopefully we'll go out and we'll explain what is a logarithm, and we'll do a few examples with it. A logarithm is the inverse of an exponential function. And you've probably seen already in your book the example they use, y equals to 2 to the power of x. And remember that the inverse, what you're basically doing is that you're just replacing x instead of y, right? So it's x equals to 2 to the power of y, and then you have to solve for what is y. And that's where a logarithm comes in. Now you have y equals to log of x to the base of 2. And that's pretty much simple if you think about it. If you do a few examples, you should be able to grasp it and understand it. Because look, if I should put it this way right here. I should put it log of x with a base of 2 equals to y. That 2 to the power of any number here should give you x right here. So if you had, let's assume for an example, you had log of 25 with a base of 5. It'll give you x, let's say x. So what you're doing basically is that 5 to the power of x equals 25. So, 5 to the power of x equals 25, that's really common sense. X will equal to 2. And that's pretty much it for this problem. You just only have to know 5 is raised up to which power to get 25. If you do another example, here, let's do some other examples. Let's see, I don't know, we can put log of 81 in the base of 3. Actually, no, actually, yeah, that can work. Alright, so this question is basically asking you 3 to the power of what to the power of x equals to 81. So what do we raise 3 up to get 81? And that's pretty simple if you think about it. We know that 3 squared equals to 9, and 9 times 9 equals to 81. So it's like 3 squared times 3 squared, which equals to 3 to the 4th, which equals to 81. So we can conclude that x here equals to 4. So we'll say log of 81 with the base of 3 equals to 4. And that's how you solve that problem. Now, we'll do some extra examples right now in order to have a better understanding of logarithms. Let's try to make it a bit confusing a little bit. Let's try to put a logarithm of 1 over 9 with the base of 1 over 3. That's pretty much the same thing. You're saying 1 over 3 to the power of what gives me 1 over 9. And we know for a fact that if fractions were to be raised up to a certain power, they actually decrease. So right here, 1 over 3 to the power of x equals 9. You don't have to worry about the 1, because the 1 to the power of anything is always going to stay 1. But instead, you should worry about your denominator, because 3, if you was to square this right here, if you was to square it, you'll get 1 over 3 squared. That's basically 1 over 3 times 1 over 3 gives you 1 over 9. So we can also say that x equals to 2. And log of 1 over 9 with the base of 1 over 3 equals to 2. Now, let's do even more problems, such as, I'm not sure, we should do some, let's talk about log, if we do a logarithm of, let's see, 625 with a base of 25. What does that equal to? Logarithm of 625 with a base of 25. I think this should come pretty easily to you. This should be a familiar number, 625. 625 is 25 to the power of x equals to 625. And what does x equal to? X equals to 2. So as you realize, it's a pretty simple concept doing logarithms. It's just, you gotta understand that it's the inverse of exponential function. Like y equals 2x, x equals 2 to y equals to 2 to the power of x, and x equals 2 to the power of y, and y equals to log of x with a base of 2. Now, there are certain properties we'll discuss in our next videos, hopefully, and we'll talk about the graphs of logarithms, hopefully. And thank you very much for seeing this video.